it was depicted by hertz and not knowledge. It was actually kind of interesting, the patterns you could find with like the hertz and notes. Yeah, J-Ho, you do look like the guy who said, man. Yeah.
Okay, guys, quiet down, please. We're gonna get started.
A little bit of my face did.
There's only 15 questions. Your quiz tomorrow is gonna be more like 8 questions.
It's on paper.
It's on paper, yeah.
It's 8.
You're always so obsessed with the number of questions. I mean, I can make a 2-question test that's extremely hard. Or a 50-question test that's very easy. It's just the number of questions is irrelevant.
The more I get wrong, like,
That's true. That's true.
Well, no, he can make the 2 questions each worth like 50.
Yeah, with 8 questions, each question's 4 points, 5 points, and you can get every question. You can get the final answer wrong in every question and still get like a decent score. Okay, so number 1 is find the volume of a solid whose base is this bounded region. So you draw the region. Okay. By the way, guys, for these like free response tests, I mean, first of all, if you just write the right answer with no work, I'll give you the point for the right answer, but you don't get any other points. So you got to show some logic. But also, if you get the answer wrong and your work's all messy and incoherent, I mean, I'll try my best, but I'm not going to spend 10 minutes trying to decipher. Like, you know, the notation's very simple. It's very easy to show your logic. So anyway, some of you guys are doing a great job at that, where you get the wrong answer, but I can see very clearly how you set it up, and I'm like, oh, there's an extra 2 in there. That's what happened. So
I also get the right answer.
and you get all the points. You get most of or you get all but one point. So. Okay, the cross sections are semicircles perpendicular to the x-axis. So you draw one of the sections, you go, okay, here's my section, and then you kind of redraw it. I think you guys said you liked it to be drawn like that. Okay, so there's the slice. What's the radius of that slice? 4 over x. Half of the y value. Right? What's the thickness? dx. And then so the volume of this slice is fuzzy wuzzy was a bear. Area of half a circle is 1/2 pi r squared times the thickness. That's the volume of a single disk or single tile, I guess, single slice. And then we integrate from
1 to 8.
1 to 8. Okay? Feel okay about that?
Mm-hmm.
Okay. So, the math here would go, let's see, what can come out of the integral and the 16? Well, I mean, you don't have to do that yet, but I'm going to take the 16, right? Half of 16 is 8. So there's an 8 pi out here. Do we feel okay about that?
Yeah.
And then what's left over inside is the 1 over x squared, which is a pretty, hopefully by now, straightforward integral for us. So it's negative 1 over x from 1 to 8. Still fine with that? Okay. If no one starts screaming, I guess I'll assume everything's okay. So plug in the 8, you get negative an eighth minus negative 1, so basically plus 1. So what number is this inside here? 7/8. 7/8 times 8 pi is 7 pi. Bada bang, bada boom. Cool beans? Do we all feel great?
Yeah.
Okie dokie.
Oh,
What's
sorry.
wrong?
No, nothing. It's just natural response to most things, Jay. Don't worry about it. It reflects nothing on what's going on now.
So this one, no calculation required. It just says, consider this region between y equals x cubed, so there's y equals x cubed, and a square root function. Where do these dudes cross?
1.
1,
Zero.
1.
Oh, okay.
So there's the region, and I'm going to draw my slices like this. Why draw the slices like that?
Perpendicular to the y-axis.
Because it says they're perpendicular to the y-axis. So let's draw one of these little slices. You say they're equilateral?
Yes.
Equilateral. So how, well first, how thick?
Y.
The y, so that means this quantity, this side length, I want to be in terms of y. So that's basically this x value minus this x value. So on this curve, my x value is the cube root of y. And on this curve, my x value is y squared. Are there any questions on those two thingies?
Nope.
Pointy. No, we feel good? Okay, and then this value is this minus this. So cube root of y minus y squared. Which it's worth noting that for numbers less than 1, numbers between 0 and 1, the cube root of that number is bigger than that number squared. So this will always be positive. Not like it really matters because you're squaring it anyway. So anyway, for an equilateral triangle, that's one we looked at. It was if this is L, then the area is root 3 over 4 times L squared. So your integral would be root 3 over 4 times the side length squared times dy. And then what are the bounds? 0 to 1. So the first 3 answers ceased to make any sense once we saw that they were all the cross sections were perpendicular to the y-axis. So it's D. Oakley could Oakley? You feel okay about that? No questions? And so if there's any ambiguity, if there was, or you felt that there's any ambiguity, this is how you earn all the points. Okay. So not like maybe that's not really necessary. Okay. Number 3. Very similar question to that one. This time, what are they? They're same thing. There's a known base, and then the cross sections are semicircles.
Yeah.
So you're gonna draw the picture. So here's y equals x squared, and then there's the cube root function. Again, they cross at 1, 1. And there's the cross sections are semicircles perpendicular to the y-axis. So draw one of the slices. Thickness. dy. Radius. So be careful with the radius. It's half of this span here. Hello, Mr. Thompson.
Hey, can I see Hannah?
Like we did in the last question, you got to rewrite this guy as x equals root y, and rewrite this guy as x equals y cubed. And so the radius is half of the difference between these x values, right? So it's the square root of y minus y cubed halved is that radius. How are our feelings about that?
Good.
Okay, so fuzzy wuzzy wasn't there. The volume of this slice is 1/2 of pi r squared times thickness. And we're integrating from 0 to 1. Now, none of these answers look exactly like that, but you could go, well, okay, I see the way they're written. Now, in free response, this is totally valid. This is 100%. This is, you don't have to go any further than this, but for the sake of this multiple choice question, this 1/2 squared can get multiplied by this 1/2 to make a 1/8, right? So which one is it then? It's the last one, F. So there's that pi over 8 on the outside. Is that a yeah, Mr. Trenton? Yeah. Yeah. That was a patriotic yeah. Good job, sir. Okay. Another one. Oh, I'll do our poll at the end of class if I can remember. Oh. Daylight savings time poll. Does daylight savings time make you Mr. Happy Face or
Why does
Mr.
that make you happy?
Sad Frowny Face? Or
I like
Does it actually help the farmers?
You
You like the what?
I like things getting a little changed, you know? I like a little bit of.
If it helps.
Yeah.
No, it's not just.
We get an extra hour of sunlight and the adjustment isn't that long.
You
I
guys
do
know the
appreciate
real
the
reason
extra
that
hour.
it exists. Because they want it to.
Happy day.
Look,
In the fall, I'm ecstatic, and in the spring, I'm sad. So like,
Yeah, I'm just constantly sad, and so like, let me be sad in the sunshine, you know?
yeah. Exactly.
I have discovered the cure for sadness with this one easy trick.
I don't know. No.
He will reveal his secrets
That's
after these
Vitamin
messages.
D.
That's an add-on.
Simply click this malware link, and you will have the secret to happiness.
Dude, I'll take
Yeah.
all the
Happiness.
adverts.
Yes, Alyssa.
So my question, why isn't like the day of spring also the day that like daylight savings happens?
That would make too much sense.
Bruh, I don't know.
That's a good question,
Why
Melissa.
would they do that?
You know what I can tell you, Alyssa, is how to calculate the volume of a solid whose base is a circle of radius 3 and whose cross sections are squares perpendicular to the x-axis. Now that is some knowledge.
Knowledge.
Here in my Lamborghini garage with my library. Here you
No, it's
go.
better than this new one.
Knowledge. You know what I like better than my Ferrari? This solid. Okay.
Do you?
Thickness, dx. Okay, now what's the span of this square? It's a square, so it's the same height and width. It's double this y value, right? Well, what's the y value? The y value is the square root of 9 minus x squared. So the length of this square, side length, is double that. Are there any questions on that logic? You feel okay? All right, so then therefore, the integral is from -3 to 3, and it's this squared. Now look at the answers. Here's the thing, so if the question asks, just write an integral for this volume, this is valid. This is 100% correct. Now if it says evaluate, you're gonna have a hard time evaluating this unless you take that extra step of actually squaring this so you get 4. Sorry. Here, look at. Will you allow me to do this? 4 times this would be 36 minus 4x squared. Is everyone okay with that? Yes. The step I'm skipping is writing 4 times 9 minus x squared. If you're wondering. So that's okie dokie. What's that? E? E. That was an epic meme. One meme where we just say the letter E. God, that was so savage. What really brings me back to the good old
What?
days.
You kind of forget that. Was that, am I a part of the loop?
Big blue
Well-
moon.
Big bloom.
Big blue moon. Okay. So
My God, what did you?
for the sake of time, let's just skip this one. It's the same thing we've been doing. I want to get to the ones where we're revolving. Revolve. There we go. So 7. So same thing. 6 is the same. Are we all okay with that? Like, so 6 is very similar to 3. Thanks. And then 5 is very similar to, I guess, number 1, or even it's also kind of similar to number 3. If we have time at the end of class, we can come back to them, but I just want to make sure we cover all our bases. Consider this region. This region. We're going to revolve that region around the old x-axis there. That there x-axis.
Not there.
So you got y equals 4 over x, and x equals 2, and x equals 4, and y equals 1. Bro, disgusting. Y equals 1, so
Disgusting.
we got to make sure we draw the picture accurately. By the way, that was an issue some of you guys had with the last quiz. I think you drew the picture a little bit too hastily, and you ended up with like a region that was way more difficult to analyze. Right. So just draw. So I'm pausing here because I'm going, well, is y equals 1 like up here, or is it like down here, or is it actually? Let's identify this point here. If this is x equals 4 and this is y equals 4 over x, then what's that? What's the coordinates at this point? 4, 1, right?
No, so that
Makes sense? So this is actually going to end up being a pointy shape. Do we understand? This is region P. Yeah?
Yeah.
Okay, so let's examine one of these cross sections. What's the shape called? What's the cross section called? Washer. 2 circles. It's a washer. Mr. Doty. Do we like Doties?
Yes.
I like them. Too much. I have to avoid them. I can't resist.
Like the fudge stripes.
Yes.
Ooh.
The fudge
That's what I was
shopes.
just thinking about.
The fudge shopes.
Those are so good. Like the hungry old.
Okay. Yeah, those, I had many times in my youth where I would eat so many and then you just feel terrible.
Yep.
Bad times. Okay.
What good.
Yeah, the elf, there's the fudge wavies. Okay, anyway. The outer radius is the distance from the axis of rotation, the x-axis, and the top. So that is the outer radius right there, which is just the y value of that curve. So the outer radius is 4 over x. And the inner radius, hopefully that makes sense. I'm drawing a little. The inner radius is just always 1. Does that make sense?
Yes.
Why is it 1?
Because the distance from here to here is always 1, because this curve is y equals 1. If there's a function on, like, there's a top function and a bottom function, it's always top function is the outer radius and bottom function is the smaller radius. That's all you got to remember. So then the volume of this, and then of course the thickness is dx. So you go pi times the integral of big radius squared minus little radius squared times the thickness. And what's your bounds of integration? 2 to 4. Now you're gonna, again, suppose you need to evaluate this. This would be a pretty easy to evaluate integral, all things considered. I mean, if, like no U subs or anything necessary. So there you go. Oh, we actually did get the answer. Oh man, who is that sadistic person who made us calculate the volume? Man, what a horrible man. Okay, so you got pi. Integrate this. So 16x to the negative 2 becomes 16 x to the negative 1 divided by negative 1. Long story short, negative 16 over x. The integral of 1 is x. And we're going from 2 to 4. We feel okay still?
Yes.
Mhm.
Great. So, plugging in 4 gets us negative 4 minus 4.
Oh my god.
Are you okay? Plugging in 2 gets us negative 8 minus 2. So this is going to be minus negative 10. So positive 10 minus 8 is 2. The answer's got to be 2 pi. That's kind of nifty. Neo burrito. Yes?
It's okay.
It's okay.
I really want to bring
You want a burrito? What type? Beef and bean? That's it? Just beef and beans. No rice?
Oh, are we talking like an actual burrito or like a garbage gas station burrito?
They're not garbage.
On contrary.
You're never too good for gas stations.
Mr. Trenton, don't eat those gas station burritos, bro.
Oh, I think I'd go for carne asada.
Probably.
Sure, okay?
Yes.
No questions? Okay. Oh, Mr. Trenton.
What?
So much.
What?
Well, there's like two types of burritos. There's like real burritos.
Well, I knew what you were talking about. I could, yes.
All right.
And then there's like those super one burritos that are so dry.
This one, we're going to take a region. So draw the region. Where are we revolving this dude? Around the y-axis. So there's the shape. Pay close attention to our bounds are going to be what kind of numbers? Or what kind of coordinates? Y numbers, y coordinates. So 1 to 3. I mean, we can already set up our integral. We know we're going to be from 1 to 3. Okay, let's look at the slices. Each of these slices is a disk, right? Thickness of the disk being dy. Radius of the disk being not so obvious, right?
No.
The radius of the disk is the distance from here to here, which if you think about it, is really just the x value of that point, right?
Yes.
What's the x value of that point? The square root of y minus 1. Cool beanies?
Wow. Not cool.
That was an emphatic yawn. I think it was a yawn.
It sounded like someone blowing their nose.
Oh.
Or like an elephant.
But
like people do.
is that, are we sure we understand this?
Sorry, what?
We understand
Yes.
Yes.
1, 2, tie my shoe? Okay, so then the volume of this disk is pi r squared. And it is asking us to evaluate, but we breathe a sigh of relief because we go, oh, wait a second. This is actually a super easy integral. What am I doing? The square cancels out the round. That's what I'm trying to do.
That was beautiful.
What am I doing?
That was beautiful.
You feel me?
Yeah.
Okay. So,
Oh boy.
there's another one. Like this, the quiz is not really a focus on integration techniques. It's a focus on this. So if you find yourself doing a really complicated integral, you have made a mistake. Just a heads up, okay?
That's
Find yourself
really
doing-
gonna help me.
Well, I mean, it's not okay. Like some of you guys,
Mayday.
Some of you guys on the last quiz, there's an integral like this, something along the lines of this.
Even point fingers.
And well, it's just a good example of like, sorry, I should have was catching this, but and some of you guys had like insane amounts of work, but this is just a circle. So you hopefully should have found yourself like 5 or 6 steps in, like, wow, this is extremely complicated. First of all, you can't even integrate this by hand.
I know.
But some of you guys were trying to, and I was like, dang, I felt bad. I'm like, oh, you probably spent a lot of time trying to figure that out. But I'm just trying to help you out here. Like the actual calculation element should be easy for you. Okay. So integral, it's y half of y squared minus y, and we're going from 1 to 3. Okay. Let's plug in the 3.
Oh my god.
You get 9 halves minus 3 minus, plug in the 1/2, you get a half minus 1. So, horrible. Disgusting.
Disgusting.
This is 9 halves minus 6 halves, which is 3 halves. And this is negative a half, so really we're adding a half. So it's 2 pi.
Oh my god.
Oh, we feel okay about that calculation? That all makes
Yeah.
sense? Okay, so, what?
I know what I'm doing. It's fine.
Mr. Paul, am I your favorite student?
Yes.
Because you lose patriotism.
Yeah,
Right?
patriotic.
I wake up in my red, white, and blue boxers. I'm just ready. I'm ready to say the Pledge of Allegiance.
Just ready.
The patriotism powering, the PP,
It's like
if you will.
in cars.
Lamau. Lamau.
If you don't understand that, you're definitely not.
For intellectuals only. Like Griffin, he's seen Rick and Morty, so. Yeah.
Yeah, dear.
Okay.
We're laughing about something. Well, I'm gonna tell you right now, I probably. No, this is. My friends will watch this animated movie.
Oh, that's a good one. It's a little too.
Okay, another question.
Is there a purpose?
We're going to revolve this around the x-axis, and we're actually going to evaluate it, so more practice. What's the x value where these dudes cross? Stinky Winky. 1 doesn't work because 1, 1, 1, 2. 4 gets us.
I do it. I had a little voice that made my head.
You feel okay?
Yeah, you did, Trinity?
Fine?
No, I don't.
Yes, we're fine.
Okay. Revolve. So each washer looks like this. The thickness is dx. The outer radius is the top function. The outer radius is 2 root x. The inner radius is x. Are you feeling okay? So the volume is the integral from 0 to 4 of pi times big radius squared minus little radius squared. We're still feeling fine about that? Oopies. We're okay?
Yeah.
No confuse? Confuse? No confuse?
None.
So pull the pi outside, square each term. So this is where you gotta be patient. This looks confusing, but when you actually do this, you go, oh, wait a second. Everything's fine.
Everything's fine. Well.
It's an easy integral. It's not anything
Yeah.
crazy.
Yeah.
Oops, oopsies. Also, another thing, make sure you're being careful with your notation. Like, since the integral of this is 2x squared minus a third of x cubed. Some of you guys are keeping that there. It's probably just like a typo, basically. But just make sure when you actually take the antiderivative, the little integral bar goes away, and it's replaced by the valuations. This is another really good way to like ensure that you get all your credit. Is like that turns into this. So once you antiderivative, you change that integration bar to an evaluation bar.
How you do a bracket on the outside?
It could be a bracket or a parenthesis. It doesn't matter.
Did you just say you can leave it?
Okay, so it's pi times, let's see, plug in the 4, and you get 32 minus 64 thirds, and then minus the 0 just gets a 0. So, how many thirds is that? 96. So 96 minus 64 is 32. So 32 pi over 3 is our answer.
Amazing.
Amazing.
Mind blowing.
Step 32, do root x minus x and then have that whole thing squared, or do you have to individually square that?
That would be very B.
Yeah.
Because because this is not the same thing as this. Those are very different things. This would actually be the integral if it said if these were square cross sections, because then it would actually be a square whose dimensions are this by this. Does that make sense? So there's a big difference between a washer and a square or like that.
So why do you have to square it?
Because this washer is so with a circle, if there's an outer radius of R1 and an inner radius of R2, then the area of this in-between washer is pi r squared minus pi r squared. And so when you factor out the pi, it's each individual radius squared. It's not, a lot of students make the mistake of just subtracting the radii and then squaring. That's wrong. You have to square the radii before you subtract. Is that a yeah?
Yeah.
What's a what?
What's a
A fruit.
I know the fruit. Like, what's the fruit look like?
It kind of looks like
Like a
a.
squash, but kind of green. Yeah.
I thought it almost
It's kind
looked
of
like a
elongated.
mango.
I think it's
More mango
really good.
shape.
Isn't it more elongated than a mango?
Yes, it's more elongated than a mango.
I like mangoes.
They're
It's
very
not-
sweet.
It's
They're
not a
like
fully
really
convex
sweet.
shape either. You feel me? You can draw a segment connecting 2 points, like a banana is non-convex. You can draw watermelon's convex. This guy, you can draw a point that goes from a point on the banana to another point on the banana that doesn't have to intersect the banana, whereas in a watermelon, you want to connect 2 points in a straight segment, you have to go through the watermelon. You feel me? True dat, true dat. You put a big old hole in the watermelon, you punch the watermelon. Now maybe it's non-convex, concave. Anyway,
Mango.
most of the solids we study are
They're very, very sweet.
cubies,
Like
dodecahedrons,
ridiculous. They're
icosahedrons,
really good though.
tetrahedrons. What else?
They're-
Prisms.
They're decahedrons are so cool.
They're savage. I know.
Yes.
Okay, well, is there really much else? I mean,
There's like.
let's revolve around a line. Let's do two more.
Let's revolve around a line.
Let's revolve around a line. Let's skip to 12.
Yes, sir. Ooh. Triple crown. Crackly.
So, sorry, where were we?
Drawing graphic.
Yeah, there's a line of x squared, and there's y equals 9. And we are about to revolve this region right here around the line y equals -1. Cool beans?
Yes.
What shape are the cross sections? They're washers, right?
Yes.
When this is the center, the axis of rotation, they're going to carve out washers. We all feel fine? Yes.
Why do they call them washers?
Okay.
That's exactly what.
That,
Well, like, you mean like beyond the answer of they look like washers? Like, why do they
Yeah.
call washers washers?
Yeah.
I don't know. Deep philosophical questions there, Caleb. I don't know. Why do they call big blue moons big blue moons? We're really getting at the root of language here, you know.
indeed.
So anyway, the thickness is dx. What's the outer radius?
The tall one.
10.
That's the one that.
9 minus -1 is 10. Yeah?
Yes.
Every single one of these points is the same distance away from this. Now, by the way, it's the same logic when I go to do, take an arbitrary slice like right here. Sure, the outer part, when it swings around, is always 10 units away from the axis of rotation, but how about this point? Well, it's this y value, which is x squared, plus 1. So the inner radius is x squared plus 1. Do we feel okay about that?
Yes.
Okay, so then the volume is the integral of big R squared minus little r squared times the thickness, and then sorry, got a Snapchat. And then where do these cross? The bounds are -3 to 3, and what did I forget? I forgot something. The pi. There's your answer. Now, looking at the answer choices, which one is it? A? A.
Oh my god.
Yes.
Just a quick question. So the x squared plus 1, why is that 1 there? Is it just because of like that negative, the y equals -1?
Because the inner radius is the distance from this point to the axis of rotation.
Oh,
So this distance is x squared, the y value of the function, and this distance is 1. So the total distance, in general, you're subtracting them. You're just going x squared minus -1.
okay.
Right. All right, one more. We're gonna revolve around the line. Do we have time for one more? Do we?
No, not really.
Yes.
Just not.
Yeah, let's all do Mr. Hobbs.
Like
Let's get through as much as we can.
We gotta do that.
We gotta do the poll.
Oh, the poll, the poll.
Oh,
yeah,
we do have to do the poll.
We have time. This is quick. We have time to set it up. Okay. Here's y equals root x. Here's y equals 1/2 x. We're revolving around a vertical line, so that should hopefully clue you in that we're going to have to do this. Rewrite these, right?
Yes.
We're going to use that, and we're going to use that instead. And we're revolving around the line x equals -3. So then we're going this way, so we're looking at horizontal distances now. So pick an arbitrary thing. Slice. The inner radius is this x value, which is y squared, minus this, which is -3. So I write y squared plus 3. That's my inner radius, right? What's my outer radius? it's this x value minus -3. Sorry, I'm getting kind of cluttered here, but this outer radius is 2y plus 3. So my integral is pi times big R squared minus little r squared. This would be a pain in the bottom to integrate. What are the bounds though? 0 up to the y value where those cross.
4. Or just 2. Yeah, 2 value.
Because they cross at 4, 2. You need the y value where they're crossing. So the final answer to this one is I think E. Oh, I guess if you already voted in physics, don't vote again. Who is happy face man about?
Yeah, George. About daylight
You're
savings.
changing your vote?
I want to get rid of my net vote and put it on the smiley face.
Yeah.
Yeah. So we got 1, 2, 3 for Smiley. 1, 2, 3. Who's frowny face? 1, 2, 3, 4, 5. Okay.
Oh,
Who's either? This could mean either indifferent or ambivalent.
I vote for frowny.
1, 2.
Oh, I already voted.
And already voted, right?
I vote frowny face.
Wait, can you add me a frowny face?
Forget it. Forget it.
Most people are frowny face.
Just add me, Melissa.
So.
I think the frowning face people are.